Hello everyone, welcome to my channel. So today we'll be discussing chapter 3 of class 12 computer science, which is working with functions with respect to Sumita Arora textbook. So first we'll see what is a function. So function is a block of reusable code that performs a specific task. So in Python, we write a function using def keyword. Here, with the help of this keyword def, we write a function, and this greet is the function name. Okay. So why do we need a function? Because it helps in reducing code duplication, improving readability, easier debugging and maintenance. Why do we create a function? We create a function so that we can, whenever we call that function, we can execute the commands that are written under that function. So we do not have to again and again write the same code everywhere. We can just call that particular function every time we want to execute that particular code, and this helps in reducing code duplication. So Python supports both built-in and user-defined functions. Like the functions that we write are user-defined functions, and that are functions which are already present in Python that are built-in functions. For example, sum. Whenever we call that sum a plus b, so that function is already like this sum. If we say sum a and b, so this sum is a built-in function. Okay. So we do not have to again define it. It is already defined in Python. Next, understanding functions. So what is function call? A function call means executing or using a function that has been defined earlier in the program, right? So like we have already created a function. Now in order to execute that function, we'll have to make a function call. Whenever we call that function gets executed. Okay. For example, here we saw that we created this function greet. Now, whenever we'll call this greet in this manner, that means we are calling this particular function greet. Okay. And whenever we'll call that function greet, this greet function will get executed. When you call a function, the control of the program is transferred to that function. After the function completes its task, control is returned to the point where it is called. Okay, so whenever we make that function call, that control that goes to that where that function is written. Okay, and it will execute all the lines that are written under that function. And then once we are done executing those lines, then the control will come back to the point from where we are calling it. So next is syntax of calling a function. So we have this function name and arguments. Like here, this is the function name greet. Okay, and here we haven't passed any arguments. So the syntax is that we have a function name and we have arguments. Okay, function name is the name of the function you want to call, and arguments are the values that you want to pass to the function. Here we haven't passed any arguments. We only have, because this is a function with no arguments. So we are defining with the help of def keyword, we'll define a function. The name of the function is greet, and these are the statements under it. And here we are calling this function. Next is function with arguments. So we have written this particular function add, and with the help of def keyword we are defining this function again, and here we have passed these arguments a and b. Okay, so and we have written the statement like sum is a plus b. So whenever we'll call this function, we'll have to pass the arguments. Like here we have passed 5 and 3, so a becomes 5 and b becomes 3. Why? Because we are passing these arguments. So, and while writing the function, we said that we'll be requiring 2 arguments. So whenever we call this function, we'll have to pass 2 arguments. So this value 5 and 3 are passed to the function as arguments. The function add uses these values to perform addition and print the result. So the next topic is defining functions in Python. Defining a function means creating a function with a name, parameters, optional, and a set of statements that perform a specific task. Here, see, when we define a function, we use def keyword. Then we write the function name. Then we pass parameters. Parameters are the arguments that we saw last time that we passed, like we passed a and b. So those were the parameters or arguments. Then we have body of the function. That means we have the statements. Like earlier we were just printing hello world, right? So this is how we define functions in Python. Now we have function using print statement. Function displays output directly on the screen. It does not return any value to the program. Like here we have this function add, and what we are doing here is we are just printing sum is a plus b. Okay, so we are not returning any value to the program, we're just printing it. We cannot store or use the result later in the program. Why? Because we are not returning it, we're just printing it. So this is function using print statement. Then we have function using return statement. Here, see, this is the function add, and here we are returning the value a plus b. Okay, so function calculates a value and returns it to the main program. The returned value can be stored, used, or printed later. So here, when we are calling this function add and we are passing these parameters a and b, we are saving the result. We are saving this outcome of this function in this variable result. So whatever value will be returning, like what the value which we are returning is a plus b, that value will be saved in result. So 5 plus 3 is 8. So the value of result is 8. So when we print sum is result, we get sum is 8. The function add return to the sum of variable result. You can now use the result in further calculations and print it. So I'll just show you on PyCharm how it's done. Okay, first we'll see using print statement, and then we'll be returning a value. So I'll create a function add, and we have two parameters here, a and b, and we'll print sum is a plus b. So when here we are calling this function, and we can pass any two values. Let's say I'm passing 5 and 3. Okay, so here we can see that a is 5 and b is 3. Okay, and we are passing these two arguments to here to this function add. So I'll just run it, and we get the outcome sum is 8. Okay. Next, I'll show you what happens when we return the value. Okay, so again, I'll create this function add a and b, and here I'll just return the value a plus b. So when I'll call this function add, let's say I'm passing these parameters again, 5 and 3, and here I'll save this in a variable called result, and then I'll print sum is result. So when I'll right click it, see, I get sum is 8. Here we have returned this value a plus b, and this value is saved in this variable result, and we are printing this particular variable result. We can also further use this variable result. Let's say if I print result plus 10. Okay, I'll right click and show. See, it gives me output 18. We have used this particular variable result, and we are again adding it to it, and we can see. So this is what we mean when we say we can use this value result again for further calculations whenever we return this. We couldn't have done this if we were just printing it and not returning the value. Okay. So the next is flow of execution in a function call. So how that entire execution, like that, how that execution flows whenever we call a function, we'll just learn about that. So when a function is called, the control of the program jumps from the main program to the function definition, and the computer starts executing the statements inside the function. Okay. See, this is the step 1. Function is called. So this is our function greet, and these are the statement that is written inside this function greet. The function call is encountered in the main program. So this is the main program. Print before function call. Here we'll start from here. Our control is here. First, what it will do? It will print before function call. Then here it is this, we are calling this function. So the control will move here. to this function definition, and we'll print hello welcome to Python. Then again control moves back here once this is executed, and then we'll print after function call. Okay, so the output will be, first we'll start from here, so it will print before function call. Okay, then it is calling this function greet, so it will execute the lines written inside this greet function. So we'll print hello Python, welcome to Python. Then the control moves back here. Okay, here. Then next it will encounter this print after function call. So it will print okay. So this is the output. Okay, and we can see how the control is flowing. Okay. Now step 2 is arguments are passed to parameters. So if the function has parameters, the value arguments from the call are copied to them. So here, this is a function add, and we are passing two parameters. We have two parameters here, a and b. So whenever we'll be calling this function, these parameters, these 4 and 6 are the arguments that are passed to these parameters a and b. So a becomes 4, b becomes 6, and we do when we say print sum is a plus b, we say 4 plus 6, that is 10. Okay, that is how it works. The arguments, if we have arguments are passed to the parameters. Okay, next, function executes its statements. All the statements inside the function body run one by one, just like normal one. So here, like we have this function show details, and we are passing this parameter name, right? So when we say show details rf, so rf is our argument. So this name will become rf. So what we'll do, we'll have print hello rf, print, then next statement is print welcome to the computer science class. Okay, so that's if return statement is present. So what happens if we were returning a certain value? So we say if the function has a return statement, control goes back to the caller with a value. So here we say we have this function square, and we have this parameter n, and what we return is we're returning this n into n multiplied by n, so n square. So when we say square of 5, so here n becomes 5. So we say 5 to 5, that is 25. So the result is square is 25. We get this output. Okay. Okay, so the next topic is passing parameters. So first is positional and required arguments. So they must be passed in correct order and number. So here we have this function student. Okay, so this is a function student. Here what are the parameters? Name and age. So when we are calling this particular function student, we are passing these arguments. So name is Amit and age is 17. Okay, so we'll just write in the first position, we'll write Amit, and here we write 17. Okay, so since this is at the first position, so name becomes Amit and age becomes 17. So it is very important in the order in which we are passing is very important. Let's say if we write 17 here and Amit here, then what will happen is name will become 17 and age will become Amit. Okay, so the order in which these parameters are being passed is very, very important, and we need to make sure that we pass these parameters in the correct order. Next is default arguments. They provide default values to parameters. See, here we have this function greet, and we have written name equals to guest. So the guest here is the default parameter. Okay. So when we are calling greet here, and we aren't passing any argument here, so what it will do is it will take this default parameter as the main parameter, and it will print this output, hello guest. But when we are passing this, like when we are calling this greet function and we are passing this argument student, so what happens is it overrides the default parameter. So here we will not get hello guest, we will get hello students. Okay, I hope this is clear. So if we are passing any particular argument, then it will take that, then that argument becomes the main argument. Okay, but if we are not passing any value and we have a default value, that default value will become the output. Next is keyword arguments. Specify arguments by parameter name. So here, like we have the student, there is this function student, and we are passing these two parameters, name and age. So here, while we are calling this function student, we are saying age equals to 17 and name equals to Anita, right? So what we are doing is we are passing keyword arguments. Okay, so we are specifying that age is 17 and name is Anita. So even if we have written age here in the first position, it will still read age is equals to 17 and name equals to Anita. Okay, if we had not written, if these were only positional arguments, then we need to be, so in case of positional arguments, we need to be careful of the order. But in case of keyword arguments, order is not important, because we are specifically specifying that corresponding to that particular parameter, what is the value. Okay, we are specifying that using multiple argument types together. Okay, so what are the rules? That positional arguments before keyword arguments, default arguments at the end of parameter list. Okay, see, so this is a function. Okay, here these are the arguments, that these are the parameters, name, age and city. City equals to Delhi is the default argument, so we'll write it at the end. See, at the end of the parameter list, default argument. And name and age, these are the positional arguments, so these are written before keyword argument. See, so these are the positional argument. Amit, name will become Amit and age will become 17. And here we have again passing city equals to Lucknow, because so this is the keyword argument. Here we are also using this default value here, but when we are passing this keyword argument, it will override the default value. So in this manner we pass it. Okay, so positional arguments are always written first, and then we in the end only we write the default argument, or we pass the keyword argument. Okay, so see here, when we had not specified city, so it will take the default value. Okay, so we don't have to specify it because we have already passed default value. But if you want to override the default value, then we'll have to write we'll have to pass whatever city we want in the output. Okay. Okay, so the next is returning values from functions. Functions returning some value, non-void functions. Okay, so we have this function defined square, and we are passing this like we have this parameter here, and we are returning this value x into x. So we are returning the square. Okay, so this is the functions returning some value, non-void function. So we are returning something here in this case. Then we have function not returning any value, void function. So here in this case we are just printing it, we are not returning any value, so it is a void function. Then we have returning multiple values. See, when in this function these are the parameters x and y, and we are returning x plus y and x minus y. So when I'm calling this function cal and I'm passing this argument 10 and y is 4, so what values I'm getting two values, because we are returning two values. So here x plus y is 10 plus 4 is 14, and here 10 minus 4 is 6. So s will become 14 and D will become 6. Okay. Okay. So the next topic is composition. Composition means using one function inside another function. Okay. Function call as a part of larger function call, that is composition. Why do we do it? Because it promotes reusability and modular design. Okay, so here we can see that. So this is our initial function square. Square of x, it will return this value x into x. Okay, we get the value of square. Now we have created this particular function sum of squares. Okay, and here inside this function we are calling this function square, and here we are passing this value a, and here we are passing this value again we are calling this function square, and we are passing this value b, and then we are adding them and returning that value. Okay, so inside this function we have called this function square, and this is what is composition. Okay, composition means using one function inside another function. Okay, I'll just show you on PyCharm. Okay, so if I have a function square, okay, and let me pass this value x here, and we'll be returning x into x. Okay, and then I'll create another function, let's say sum of squares, and here I'll pass the values a and b. So I'll return, so I'll just call this function square of a plus square of b. Okay, so I'll just call this function sum of squares, and let me pass this value 2 and 3. Okay, I'll right click here and run it. I'll have to just print it here. See, the output is 13. Okay, so here a becomes 2 and b becomes 3. Square of 2 is 4, right? Square of 2 is 4, and then we'll add square of 3, which is 9, and 4 plus 9 is 13, and this is our output 13. Okay, this is the value that we are returning. Okay, so this is how it is working, and this is what composition means. All right. Okay, so the next topic is scope of a variable. What is the scope of a variable? Scope means the part of a program where a variable can be accessed or used. Okay, a variable is not visible everywhere in a program. It depends on where it is created. For example, if we have a certain function, okay, and within that function we have two variables like a and b. So that doesn't mean that a and b will be accessible from everywhere. They are specific to that particular function, so they'll be accessed from that particular function only. Okay, so that is how that scope of a variable is defined. It depends on where that variable is created. We have types of scope in Python. We have global scope and local scope. We will learn about both these scopes in great detail. So first is global scope. A global variable is declared outside all functions. It can be used anywhere in the program, inside or outside function. Okay, so what do we mean by this? Here, this x is equals to 10. This is a global variable. This is declared outside all functions. So it is not part of any function. Okay, it is declared outside all functions. It can be used anywhere in the program, inside or outside functions. So this way, global variable, we can use it inside a function. We can also use it outside a function. I'll just show you on PyCharm by executing it, and then you will get better idea. So my global variable is x, which is 10. Okay, so this is the global variable. Okay, so I'll just create a function show, and here I'll print inside function x, and then I'll call this function show, and then I'll print outside function x. Okay, I'll just right click and run it. See, so inside function x is 10 and outside function also x is 10. Why? Because x is a global variable and it can be accessed from inside the function. Also, it can be accessed from outside the function. Okay. Okay. So we just saw what is global scope. Now we'll see what is local scope. A local variable is declared inside a function. It is accessible only within that function. You cannot use it outside that function. Okay. So here we have this function show, and inside this function we have this variable y equals to 5. So y equals to 5 is the local variable, and this can be accessed only inside the function. If we'll try to access y from here outside this function, we will get an error. Okay, so that is what local scope means. The scope of this variable is only within this function. Scope of this variable is limited to this function. We cannot use it from outside the function. Okay, so I'll just show you a complete program of local scope and global scope on Python so that it becomes clear. The understanding of local and global scope becomes better. Okay, so let's say we have these global variables, room temperature, and the value of room temperature is, let's say, for 25. Then we have outside temperature, and which is 32. Okay, so we'll create a function called measure, and inside this measure we have these local variables. So these are our local variables. Sensor temperature, which is 27. Then we have CPU temperature, which is 45. And here I'll print inside function sensor temperature, CPU temperature, and then I'll return this value sensor temperature. Okay, and then create another function show global, and what I'll print here, I'll print global room temperature outside temperature. Okay, then I'll just print main room temperature outside temperature. Okay, so I'll create this variable with measured value, and here I'm calling this function measure. print returned from measured value, and last we'll call show global. Okay, so this is our function. Here we have these are the global variables. Then we have this function, and specific to this function we have these local variables. Okay, then inside this show global I am accessing these global variables, right? And when I'm calling this measured value, here I'm calling this function measure, and I'm saving the result. It is returning this result, sensor temperature, and this I'm saving in this measured value, and I'm printing this value. And then I'm calling this function show global. Okay, so when I'll right click here, what do I get? See, the first thing here I get is main room out 25, outside 25, outside 32. So here this first here, when I'll execute this program, it will come here. First it will come here, it will print this value, main room temperature. And what is the room temperature? Room temperature is our global variable, and the value is 25. Then outside temperature, value of outside temperature 32. So here I'll print it, and this is the value, this is the result. Okay, this will get printed. Next it will come here. Now it is calling this function measure. Okay, when I'm calling this function measure, our sensor temperature is this, CPU temperature is this. So what we'll print? We'll print inside function sensor temperature value is 27 and CPU value is 45. Okay, now next it is returning measured value, returned from measured value. Measured value is, it is returning, what is it returning? It is returning the sensor temperature, and value sensor temperature is 27. Okay, it is returning value 27. So here it gets returned from measure 27, and then it is calling this show global function. Now what is inside this show global function? It is in global room temperature. Now what is the room temperature? 25. Okay, and outside temperature is 32. So since these were the global values, so we could access them from anywhere, even from outside, or as well as from inside a function or outside the function. These were accessible from anywhere. These were global variables, and these are the local variables which are specific to this particular function. So they can be accessed only inside this function. Okay, so here let's say this is our global scope, global environment. Okay, so we saw there were two variables, room temperature, okay, and the value was 25, and we had outside temperature, and the value was 32. Okay, and then here we had this local environment. Within that global environment we had this local environment. Okay, and inside this local environment we had this sensor temperature, and the value was 27, and we had CPU temperature, and the value was 45. Okay, and outside here in the global, we had this room temperature, and outside temperature, and we had this measured value. Okay, and the measured value was, we were returning that sensor temperature, and that was getting stored as the measured value variable. So the value was 27. Okay, so this is how it works. These global variables, this room temperature, outside temperature, they can be accessed from anywhere. Okay, these local variables, they are only accessible to that particular local function where they are created. That is that scope of that function, and whatever value will return to the main function, that, like here in this case we were returning measured value, that is again, that becomes the global variable. Okay, I hope this is clear. So, like, in order to understand it in a better manner, we have this real life analogy for global scope and real life analogy for local scope. So, in case of global scope, let us imagine a school with school notice board. Any student or teacher in the school can see that notice board. It is publicly visible to everyone. It is just like global variable that can be accessed from anywhere in the program. Okay. And for local scope, we can think of a teacher's classroom attendance sheet. It is used only inside that class. Another teacher or class cannot access it. Once the class ends, the sheet is put away, similar to how a local variable disappears after the function ends. Okay, so that notice board is global variable, and that teacher's classroom sheet is with that particular teacher is only accessible to that teacher. Another teacher or class cannot access it, so that becomes local scope. Okay, I hope this example is clear. Okay, so the next topic is name resolution, resolving scope of a name. So what is name resolution? So when Python sees a name like a variable, it must decide which value that name refers to. And this process is called name resolution. So like when we have a variable, like when we encounter any variable, we check like if whether it is present in local scope inside a particular function. Like if we are looking it inside a function, so we see if it is present within that function, or if it has a global scope, it is present outside, or whether it has enclosing scope, or whether it is a built-in variable. Okay, so the standard rule in Python is called LEGB, which is searched in this order. L is for local, E is for enclosing, G is for global, and B is for built-in. Okay, so first Python checks whether within the local environment, okay, which is called local namespace. If that particular variable is present, then Python uses its value. If not, then Python checks it in the enclosing environment. Okay, so first step is to check in the local environment, and if it fails to find it in the local environment, then it checks in the enclosing environment. Enclosing environment means within the nested function. So we have a particular function, and inside that function it will check first. So it does not find it there. So it will, if it has any outer function, it will check there. So that is the enclosing environment. Now it checks it there. Now if it is unable to find it there as well, then it checks it in the global environment, whether that variable is present with the same name in the global space. If yes, then Python uses its value, or else it moves to the it at last it checks in the built-in environment that contains all the built-in variables and functions of Python. If it doesn't find it there, then Python would report the error. Okay, so this is how it moves. First of all, it will check in the local space, then enclosing space, then global space, and last in the built-in namespace. And if it is unable to find it there, then it will say that there is an error, this variable is not present. Okay, this is how it looks for it. So first it will look at the local namespace. Okay, so here first it will look here, then it will look at the enclosing namespace. Okay, here. Then it will look at the global namespace. And last it will look at the built-in namespace. Okay, so at first it will look here in the local namespace, then it checks in the enclosing namespace. Then if it is not present even in the enclosing namespace, then it will check in the global namespace. And finally, it checks in the built-in namespace. And if it is not present even in built-in namespace, then that means that variable is not present at all. Okay, and we report an error. Okay, so I hope this name resolution is clear. So the next topic is variable has global scope but not local scope. So what does that mean? Like we see here, this rate, it's a global variable. Okay, this rate is a global variable. Now inside this function, when we're using this variable rate, so it says rate is not defined locally, but Python will look for global space. So first it will check here inside this function show only. Okay, it will check inside this function show, and it will see whether that variable rate is present or not. So if that variable rate is not present, that means it does not have local scope. So it will check outside. Now since there is no any, it is not an any nested function, so there is no enclosing scope to check. So then it will check globally. So we find it globally, so it does not give any error. And this rate, we see that rate has value 12, which is because it's a global variable. Okay, I'll just show this on PyCharm. Okay, so I say x is equals to 50, and then I have this variable print and then I call this function show. Okay, so if I'll right click here and run it, it says value of x is 50. So here we say this x was not present locally inside this function. So when first of all it will check inside this function, and then because it does not find it here, so it will check globally, and it is present globally, so we get the output value of x 50. Okay. A student asks for class notice board for the holiday date. If it's not written on their desk local, they look at the common notice board global and find it there. Okay. So if a student they want to see the holiday date, and so they first check it on their desk. So that is the local scope. And since it is not there on their desk, so they go outside and see it on the notice board. That is the global scope. Okay. So I hope this makes it clear. Next is variable neither in local scope nor in global scope. So here we see like we have this example. This is our function, and this is we say print price is price. Now price is the variable. Now we find it locally, but locally we have no value for price here defined inside this function, so we check it outside. Now we see that globally also this is not this variable is not present. So what happens is it gives us error. It gives us name error, name price is not defined. Okay, so we encounter this name error, name price is not defined. You can understand it using real life analogy, like if you ask your teacher for exam date and it's not on local desk, it's not on your desk, and it is also not on notice board, and there is no default source, so nobody can tell you, right? Now this is now the next thing is same variable name exists both locally and globally. Reading local shadows global only if defined locally. So what we have, this x is equals to 50, which is a global variable, And inside this function show, we have x is equals to 20, which is local variable. So when we'll print inside function, it will read the local variable, and when we'll print the outside function, it will print the global variable. This is how it happens. I'll just show it on PyCharm and you'll understand better. Okay, so x is equals to 50, which is global variable. Then we say define show x is equals to 20. Now x is equals to 20, it's a local variable. Then we print inside function x show print outside function x. So I'll right click here and run it. So I get inside function x is 20, outside function x is 50. Okay, so inside function here, it will read this x here. X is 20, which has a local scope. But once we'll move out of this function here, it will read this x is equals to 50, because local variable has local scope. Okay, that is why this x is 20 and this x is 50. Okay, next is assignment without global unbound local error, common pitfall. So here we have this count is equals to 5, which is a global variable. Now inside this function increase, we say count is equals to count plus 1. But this count variable is not present, is not defined locally. So we encounter an error. Okay. So it gives unbound local error. It says local variable count referenced before an assignment. So I'll show you on PyCharm. Okay, so we have this variable count is equals to 5. It's a global variable. Now I'll create a function increase and I say count is equals to count plus 1. Okay, and then I'll print inside increase count equals to count. Okay, so I'll just call this function increase here. So when I'll right click here and run it, it says unbound local error, local variable count referenced before assignment. Okay, so we encounter this particular error. Okay, because here it will inside this function, this locally this count variable is not defined. Okay, see, if I'll write here count, let's say count is equals to 10. See, now it will not give us this error. We will get count is equals to 11 because it could find this variable locally. But here it couldn't read here. Okay, so the next topic is enclosing scope. So if we use nested functions, Python will also check the enclosing outer function scope before global. So here, this is the inner function, this is the outer function. So if it is unable to find the variable inside the local scope, it will check inside the enclosing scope. And if it finds it in the enclosing scope, that means that it is resolved and it will print that particular value. Okay, I'll just show it on PyCharm. Okay, so here we have an outer function. Okay, and inside this outer function we have a value called val. Then inside this we have this inner function. Okay, so I say print val, and here inside this outer function only I'm calling this inner function. Now here I'll call this outer function. So when I'll right click and run it, it gives me 200. Why? Because see, this was the inner function, but it did not have this value val defined here. So we check it here in the outer function. So this is the enclosing scope. Okay, so it could find it here. So it has printed it, and when we called inner inside this outer function, so we printed this value. Okay, I think this is clear. Okay, so the next topic is mutable, immutable properties of past data objects. So when we pass a variable to a function, Python behaves differently depending on whether the object is immutable or mutable. So whenever we are passing a variable, like we saw, we passed arguments. So like whenever we are passing a variable, Python behaves differently whether the object is mutable or immutable. So mutable is which the values which cannot be changed, like int, float, string, tuple. These are mutable data types. And mutable are like list, dictionaries. These are mutable data types where values can be changed. So what kind of object we are passing? So Python behaves in a different manner according to the type of the object. Okay. Like Python variables do not store data themselves. They simply act as reference that point to the memory location where the actual value is kept. Okay. So we know that in Python, we do not specifically store data. The variables do not store data. They are referring to the point, to the memory location where the actual data is stored, right? So what happens is, okay, I'm just reading these lines from Sumita Arora textbook. It states that depending upon the mutability and immutability of its data type, a variable behaves differently. That is, if a variable is referring to an immutable data type, then any change in its value will also change the memory address it is referring to. But if a variable is referring to mutable data type, then any change in its value of mutable type will not change the memory address of the variable. I'll just explain this. Let's say we have these values. A is equals to 20 and list 1 equals to 30 and 40. Okay. So we have these values here: 10, 20, 30, 40, 50. Okay, let's say this is stored at this position 2, 8, 4, 6, 0, 0. This is stored at position 2, 8, 4, 6, 0, 4. Okay, so here what happens is this variable a, okay, variable a is referring to this particular memory location. Okay, so a is referring to this particular memory location. We will not say that a is storing this particular variable. A is referring to this particular memory location 284604 where 20 is stored. Okay, and list 1, okay, list 1 has two elements 30 and 40. So 30 is referring to this particular memory location and 40 is referring to this particular memory location. Okay, so here A stores the memory reference of integer value 20, that is 284604, and it is currently storing 20. Okay, and this is the memory address of list 1. Let's say the memory address is 31312,400. Now let's say we do A is equals to A plus 10. Okay, and we change list 1 1 for the value at index 1 to 50. Okay, now our A will refer to value. Earlier A was 20 plus 10 is 30, so it will refer to this value. So now A is referring to this value 30, and this list 1 where it has two elements 30 and now it has 50 at first location, so this will refer to this value and this will refer to this value. Okay, and the memory location here where the address where list 1 is stored, that is 312400. It will remain same, but the memory location where A is referring to is now 284608. Okay, so this is the memory location where A is referring now. Earlier it was referring to memory location 284604. Now it is referring to memory location 284608. So this has changed. Okay, but the list 1 was earlier also it was at this particular memory location, and now also this is at this particular memory location. Why? Because list 1 is mutable. Okay, list is mutable and integer is immutable. Okay, so inside list 1 this index 1 it changed its value, but the memory location like where the list 1 was referring to will remain the same. So here we see that when we changed the value of A, the memory address it was referring to also changed, right? But for list, the memory address that it was referring to, that was 312400, it remained the same. I'll just repeat these lines again. Okay, depending upon mutability, immutability of its data type, a variable behaves differently. That is, if a variable is referring to an immutable type, then any change in its value will also change the memory address it is referring to. Okay, so here it was the variable is referring to an immutable type, like integer is an immutable type. Then any change in its value will also change the memory address it is referring to. But if a variable is referring to mutable type, like list, okay, then any change in its value of mutable type will not change the memory address of the variable. I hope this is clear. Please refer to Sumita Arora textbook again and read those pages again if this is not clear. Okay, so this is what this particular paragraph means, right? Okay, so the next is immutable objects example. So changes inside the function do not affect the original value. Okay, here we have value of x is equals to 10. Then we are calling this function change name number, and we are adding plus 5 to it. So here the inside function, the value of n will change to 15, but outside function the value of x will remain 10. Okay, I'll just run it on PyCharm and show you. Okay, so this is my function change num, and I'm passing this value n here. So let me just print initial value passed, which is n. Then we'll say n is equals to n plus 5, and then we print inside function n. Okay, here x, value of x is itna, and then we call this function change num, and we pass this value x here. Okay, I'll print outside function x. So I'll just right click and run it. Here, see, initial value passed is 10. Here first, like the control one, initially it will first, there's this function is there but we haven't called it here. Then it comes here, then it reads x, value of x is 10, then it calls this function change number. So when this function is called, so it will go inside this function. So first of all it will print this value, initial value passed. Initial value passed is 10 because here x we were passing is 10. Then we say inside function, inside function the value is 10 plus 5, 15. Okay, and then we'll come outside function. Outside function, it will take this particular value and again it will print outside function value is 10. Okay, I'll just explain with the help of diagram. So let's say we have these values, 5, 10, 15, 20. Okay, these are saved as at memory location, let's say 240, 244, 248 and 252. Okay, so we have this global variable x. Okay, and x initially it is pointing to memory location 10. Okay, so here this is global environment. Okay, next, when we encounter that function, okay, when that value is passed initially and we are printing that value, so at that time the value of n was still the same as x, right? So here, like this is step 1. Here the value of x, which is at global environment, it remains same at, it remains same at 10. So value of x remains same at 10. And we have this local inside the local environment, let's say this is the local environment, and here we have this value n. So value of n right now is at position 10. Okay, initially when we were just printing the value. Okay, next, so x again will point to this particular location 10, and here we have changed this value of n, like n is equals to n plus 5. So this value of n, so n will now point to the list location 15. So this is our local environment. Okay, so I hope this is clear. According to the program we saw, initially our like local environment, we had this value x, variable x, which had value 10. Then when we moved inside the function, we passed that value. Initially that the value we passed was simply 10 only, n was 10. But then we changed the local value and we added 5. So n became 15, right? But the value of x, it stayed the same. Okay, it is still referring to that particular memory location 244 where 10 is there. Okay, so this is how it behaves. I hope this is clear, that why the value of n x stayed the same even when we were changing the value of n locally. Okay, the value of n changed locally, it referred to another memory location when the scope was local, but outside in the global scope the value stayed the same. Okay, so the next topic is mutable objects example. So change inside the function affects the original value. Here what we are doing is we have this list of numbers 1, 2, 3. Then we are adding an item to this list. Okay, we are calling this function add item, and inside this add item function we are appending this value 100 to the original list. Okay, and then we are printing that inside function, that list, my list, and outside also we'll see that the list has changed. I'll just show it on PyCharm. Okay, so here I'll just create this function add item. Inside this function I'm passing my list. Okay, so initially we have this list numbers is equals to 1 2 3. Okay, then I'm calling this function add item, and I'm passing numbers here, and I'll print outside function numbers. Okay, and here what I'm doing is I am appending my list dot append 100, and I'll print inside function my list. Okay, I'll just right click here and run it. So here inside function my list is 1 2 3. See, here I'm calling this function add item. So here it is printing inside function my list 1 2 3, and we have appended this value 100. But we also see that outside function list has also changed. Okay, why has it changed? I'll just explain it through the diagram. Okay, so we have these values 0 1 2 3 and till 100 and so on. Okay, and here we have this list. Inside this list, like this is the 0th index, this is the first index, this is the second index. Okay, and here at 0th index I have value 1, at second index I have value 2, and at second index we have value 3, and this list is stored at memory location 324000. Okay, this one is referring to this position 1, this 2 is referring to this position 2, this 3 is referring to this position 3. Okay, and inside the global environment we have this value numbers, we have this list numbers, and this list number is referring to this. Okay, next here we, inside that particular function we appended that value 100, so our list became 1 2 3 and 100. Okay, and this is a particular memory location 324000. Okay, so now here inside our local environment, which was this add item function, this my list will refer to this. Okay, and here in our global environment this list numbers again will refer to this list. Okay, so when we change something inside the list, even in our local scope, right? That is reflected in our global scope as well. So the list is permanently changed. I hope this is clear. What is the difference when we use mutable type of objects, and what is the difference when we use immutable type of objects? Since list was mutable type of object, so we saw that the changes inside the local scope are also reflected when in the global variable, right? And in case of immutable, that change is not visible. Okay, that value is not changed because it is referring to the memory address. So I hope this thing is clear now. So here we conclude our chapter 3. In this chapter, we learned that functions help in breaking a program into small reusable blocks of code. We understood how to define and call functions, pass arguments and parameters, and use return statements to get results from functions. We also studied the difference between local and global variables and how Python handles variable scope. We finally learned about mutable, immutable objects and how changes behave when data is passed to functions. Overall, functions make program easy to read, debug, and reuse. Okay, so this was our chapter 3, and I hope this chapter 3 is clear. And you can tell me in the comments if something is not clear or if you want me to explain the topic again. Please let me know. Okay, thank you. Happy learning.